Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 2 for this week. And we're going to talk about temperature measurements. And so the only logical thing in my mind to say about that was, let's see if we can't scale things down. All right. So first, the Fahrenheit scale, the one that all Americans are familiar with, invented by a guy by the name of Daniel Gabriel Fahrenheit, a Dutch physicist. He was born May 24th, 1686, and I tried to look this up. I believe that is pronounced Gdańsk, Poland, but if I'm wrong, please tell me. But May 24th, 1686, and then passed away September 16, 1736 in The Hague, Dutch Republic, which is now known as the Netherlands. He invented the mercury thermometer back in 1714, and 10 years later proposed the Fahrenheit temperature scale in 1724. And on that scale, the freezing point was 32 degrees Fahrenheit, and still is, and the boiling point at 212 degrees Fahrenheit. Then we had the Celsius scale, invented by a gentleman, Anders Celsius, who was an astronomer. He was born in 1701 in Sweden and died in the same location in 1744, so not a very long life for him. He proposed the Celsius, also called the centigrade scale, in 1742, and the freezing point was at 0 and the boiling point was 100, and it's generally accepted around the world that that's easier to remember than 32 and 212, okay? But that's what it is, and we'll talk more about that in just a little bit. And then the Kelvin scale comes along, William Thomson Kelvin, and this guy was one of the more distinguished scientists of his time. He was an engineer, a mathematician, and a physicist. He was born in 1824 in Belfast in Northern Ireland, died in 1907 in Scotland in December 17th, and he proposed the absolute temperature scale in 1848. And the idea behind it was that the volume of a gas should be 0 at a temperature of minus 273.15 degrees Celsius. Basically, 0 Kelvin is where all molecular motion stops, okay? Nothing's going on. The world is dead, okay? So it's a theoretical but real temperature scale, and the scale was later named after Lord Thomson, or William Thomson Kelvin, also named as Lord Kelvin, and so today it's known as the Kelvin scale. So, absolute 0 on these three different scales. 0 degrees Kelvin, again, everything is not moving anymore, and that's equal to minus 273.15 degrees Celsius or minus 459.67 degrees Fahrenheit. Okay? Now, one interesting thing that you may not know, that the Celsius and the Fahrenheit scales cross at minus 40. Okay? So, at minus 40, it's 233.15 Kelvin, but minus 40 degrees C and minus 40 degrees F. They're exactly the same at that temperature. The freezing point is 273.15 Kelvin, 0 degrees Celsius, or 32 degrees Fahrenheit, and the boiling point, 373.15 degrees Kelvin, 100 degrees C, or 212 degrees Fahrenheit. So, how do you go from one to the other? Well, there's some pretty simple mathematical equations for this. If you want to go from Celsius to Kelvin, you simply add 273.15 to the Celsius temperature. So, let's say the Celsius is minus 273.15, absolute 0. You add 273.15, you get 0. That's what it is in Kelvin. If you're going the other way around, let's say that Kelvin is 0, absolute 0. You subtract 273.15 and you get a Celsius temperature of minus 273.15. Then from Celsius to Fahrenheit, it's a little bit more complex. Let's say you want to go from Fahrenheit to Celsius. Well, let's say the Fahrenheit temperature is 32. So you subtract 32, you get 0. 5 ninths times 0 is 0, and so the Celsius temperature is 0. But supposing you want to get a little bit more complex than that. So let's say that the Fahrenheit temperature is 50. And so you take 50 minus 32 and get 18. And you take 5 ninths times 18 and you get 10. Okay? So 10 Celsius is equal to 50 Fahrenheit. If you want to go the other way around, again, if Celsius is 0, 9/5 times 0 is 0, add 32, that's the Fahrenheit temperature. Let's say that the Celsius temperature was 20. Well, 9/5 times 20 is, I believe, 36, and then you add 32, and you get 68. So the Fahrenheit temperature for 20 degrees C is 68. And by the way, and this is the nerd in me coming out, you know those bank thermometers that at least used to flash both the Celsius and the Fahrenheit temperature? And so being the geek that I was and still am, I would look at that one and I would try to figure out in my head what the other value was before it popped up on the bank thermometer, okay? So let me tell you just a little bit about my simple theory on this, okay? We know that 0 Celsius is 32 Fahrenheit, okay? That's sort of easy to remember. We also know that for every 5 that the Fahrenheit goes up or down, the Fahrenheit goes, did I say that right? For every 5 that the Celsius goes up or down, the Fahrenheit temperature goes up or down 9, okay? So let's start at 0 and 32. We add 5 to 0. Now we add 9 to 32 and get 41, okay? Now we're going to add another 5 to the 5 Celsius, and now we're at 10. We add 9 to 41 and get 50. So 10 is 50. 15, 59. 20, 68. 25, 77. 30, 86. You see what I'm doing? I start off at a base. I increase this side 5, this side 9. And so I just keep going like that up the scale. And after a while, you'll remember that, like, 5 is 41, 10 is 50, 15 is 59. And so if you see a bank thermometer that says 12, you'll say, okay, I know that 10 is 50. I know that 15 is 59. 12 is sort of in the middle. So I bet it's like 54, 55. You know, so you can come up with a really quick estimate, but you have to practice. you got to practice to get some of those base numbers down. All right. So in conclusion, Fahrenheit was first, so we can, yay team. All countries in the world use Celsius except us. Now, I've heard all sorts of arguments as to why we don't, like how do you define a dash of this and a dash of that in a recipe, and there is no Fahrenheit to Celsius conversion for that. I don't know. All I know is that every country in the world uses Celsius except the United States. And Kelvin is simply an international scientific scale. No normal human beings or civilian human beings use it, but it is widely used in the scientific community. In fact, all the equations in meteorology use Kelvin. So when I download the raw data from these numerical models, all those temperatures are in Kelvin, and then I have to write a little script to say, okay, convert that to Celsius or convert that to Fahrenheit, and then it does it for me, so it's no big deal. All right, that is it for today. Bonus weather video number 2 for this week. We hope, or I hope, you have a wonderful weekend. Again, as I mentioned in my daily weather update, if I do decide to drive to the mountains to see some of the snow, I will definitely share at least one, if not more, videos with you on that. And I guess that's about it for now. So you all have a great weekend, and we will talk to you again on Monday, if not sooner. Take care.